Hi people, welcome to another LeetCode Daily Challenge. Today is 16th of July and the question for today is step-by-step directions from a binary tree node to another. Okay, so the question is we're given the root of a binary tree with n nodes as each node is unique. Okay, and then we're also given a start value representing the start node and a different integer destination value representing the value of the destination node. Okay. Now from find we have to find the shortest path starting from the node ending at ending at node T. Okay. Got it. So we have to give the directions of how we'll reach one node from another. So if we start at 3, I have to tell how I will I reach 6. So it is up, up. Yes, this is right, and then left. Okay. This sort of looks like a graph traversal, but the directions here are okay. So what can we do? Let's see. Just take this example only. So 5, 1, 2, 3, 6, 4. 5, 1, 2, 3, 6, 4. Now we have to reach from 3 to 6. Okay. So like we already know that for each node, the L and R are available, right? So from 2, I have the L pointer and the R pointer already there. What I don't have is an upwards pointer. So let's say somehow I'm able to add this up pointer. Okay, so imagine somehow I have the up as well. How we go about doing that? We'll think about it. So okay, so I'll start as 3. Okay, so for from 3 we can have 3 directions. One is left, one is right, one is up. Got it? So let's say we use. How are we doing this? Okay, let's not do this. So we are starting at 3, correct? So let's, if I take L, I'll be at, this would be the new pointer. Okay, so I'll be at a null pointer, so I'm calling it n. If I take a right, I'll be again at a null pointer. If I take up, I'll be at 1. Got it? So these two cases we'll just not consider. So we take up and we go to 1. Now from 1, so this is okay, so I'll write it here. U is my first this thing. From 1, I have again left, right, and up, 3 options. Now from 1, if I go to left, I'll have 3. But let's say we have a visited array as well. In the visited will tell me that 3 is already visited because from 3 we went to 1, so 3 won't be considered. Right would be null, not considered. Up would be 5. So we have again 1 up and we are at 5. Now from 5, I can have left, which is 1, visited, right, which is 2, and up, which is null. So not considered. So this is one a possible scenario. Till now we don't have any, two scenarios possible, but let's we can think about that also. Um, yeah, from 2 we have left is 6, right is 4, up is 5. 5 is visited, let's not consider this. Now 6 is also there and 4 is also there. So from here we sort of will have a path splitting. We can take left, we can take right. Left will lead me to 6, right will lead me to 4. Correct? Now 6 and 6 is our answer. So UURL would be the final solution, UURL. But imagine from 6, from let's say 4, we had 2 more, 7, 8. Correct. So what would we do in that case is what I'm trying to plan out. So let's say from 6, 6 is this path. I'm at 6. I can take left, which would be null, right, which would be null, not considered, not considered, up, which would be 2, already visited, nothing happens. From 4, I can take a left, which is 7, right, which is 8, up, which is 2, already visited. So again, okay, not this one. From R, we have two paths. One is L, one is R. L is taking me to 7, R is taking me to 8. Now, whichever is my answer, let's say 7 is my destination, which answer would be U, U, R, R, L. Got it? So we're basically just doing a, what is this? BFS call or a DFS call, anything is fine. I think if the tree is very big, let's do a BFS call instead, so that we are not just like randomly traveling on paths that are of no use to us. So BFS. would be a good approach here. But firstly, let me, how will we do this? Add parent pointers so that I have access to it. Next, what I'll do is start BFS from start value and end at end value. Okay. So for to add parent pointers, what I'll do is I have the root. Correct. Let's make a map. This would be integer, comma. I think there should be tree node. Yeah, tree node. Got it. So tree node. I'm calling this pair. Now pair equals to new. Okay. I'll make a pass the root, and initially it will be a null pointer. So null because root's parent is null. Correct. I'll create this void method node, the node which I'm talking about, and tree node, the parent. I'll call it P because we already have one pair. So if current equal null, let's not do anything. Return. Otherwise, parent dot put cur dot val, correct, yeah, val, and the parent is P. Correct. Now we have to make two call parents. Cur would be cur dot left. This would be cur. Okay, so let's say we have the entire parents point, all the parents pointer constructed for it. Now let's make, what do we need? I'll start from three, and I have three directions to explore. Two are, one is left, one is right, one is up. Okay, and the direction which I'm going in, I need to store the path. Yes. So I sort of need, so BFS call, we do it through a queue. Now in a queue, I need to put the path as well as the current node. Correct. So let's say I am reaching five. Correct. How did I reach five? What is the path I took? So that is a like a int comma string this thing, but we don't have a pair structure in this. So I can create a new class, but I don't want to do that. Let's do one thing. I'll make a string array, like this, and then the first one would be the value which I'll explicitly convert to int. The second one would be the path. So let me make a queue v. This would be string array, call it queue only. And then I'll add queue dot add, that would be start value. Okay, so we need a pointer to the start as value as well. Oh yeah. Okay, and that this is sort of increasing our work. And because in this queue now I can't store the string. Yeah, it is a bit difficult. Let's do one thing. Instead of this, let's make it tree node. And what I'm going to additionally do is class pair. Pair would be tree node dot node and tree node and string path. Now this tree node in node string path. This dot node would be node, and this dot path would be path. Okay, and what I will do is I'll put pairs in this. The pair class would be linked list. Okay, now queue, what do I need to add? I will add a new pair. Okay, I will still need reference to the start value. Okay, tree node. What is this node? Can I store? Maybe I can. I don't need to create another. What do I have here? So we have the parent. So I'm thinking, one. So we'll have to remove this. Since we are tree node, uh, I was thinking of storing the start value as a node. So let me pass the start value also here, and s. Let's call this. Keep it simple. Parent is getting called from here. So start value. And so let's do one thing. If this happens, everything happens. If s equal cur dot val means this is the start node equals to cur. So let's say we have the start node as well. So what we're going to do is when we start our code, we have to start with the start node, correct? Whose value is start val, correct? Let me add this in the queue. Queue is a pair. Pair has two properties. One is node and one is path, correct? So new pair node would be the start and path would be empty string, correct? Now what we need to do is while queue dot is empty, so while we have something in the queue, what we're basically going to do is firstly let's pop out whatever there is in the queue. Pair, can I call it p? Let me call it pair only. Pair, um, let's just call it pair equals to queue dot poll. Okay, so it has both the path and the node that we are working with, correct? Now what we need to do is we need to traverse in three directions, correct? So for that, firstly we'll need a visited this thing array. Let's call it array, or let's call it what are the values? Values are 1 to n. Okay, I'll make it a set. Keep it simple. Set don't matter if I make it inside here. Set, and this is integer and integer visited. Okay, so we have the set. Now firstly what we'll do is whenever we're adding something, we have to mark it as visited. So visited dot add start value, meaning start value is already visited, correct? Okay, so I have the pair p. I need to go in three directions, correct? So tree node up, we'll get it somehow. Tree node left, tree node right. Okay, so these are the three directions that we need to go. Where will up come from? Up will come from this map parent. So parent dot get um, pair dot node, correct? um, pair dot node dot left and pair dot node dot right, correct? So we have all the three directions that we need to go. Now at a time what we need to do is should I write a method for this? Okay, we have the queue. Yeah, let's call a method validate and add. This method would be up. Next would be the queue that I need to add this into, and the path would be u. I'll tell you what this method does. So basically I'm just trying to prevent some repetitive coding. Private void, let's bring this here. First one is queue. Next is okay, the tree node, let's call it next. And then there is a queue, and then there is a string path, I'm calling it p, correct? Well, I need okay, yes, string p. Hmm. Okay, I need to pass the entire thing. So pair dot path plus u. We have the full path. Now, if next equals to null, will return. No need to do any add anything anywhere. Return. Now, if this is null, or this dot contains next dot val. Okay, so it is visited, then also don't need to do anything. Um, Let me, you know what, just getting complicated unnecessarily. Um, so what I need to do is, if up is not null and base dot contains um, okay, so if up is not null, there is a parent and the parent is not visited. In that case, what I'll do is q dot add will be a new pair, which will be the node would be up and path would be pair dot path plus u. Correct. So because we're going up, right? Now we need to repeat this for all the three. So if left is not null and visited does not contain left dot value, if right is not null and doesn't contain right dot value. So for left this will be L and for right this will be R. Correct. So we got all of this handled. Where am I adding it as visited? That is a good question. Let me add it here only. Vis dot add u comma pair. Okay, 1 second. U up node pair dot path. Okay, cool. Vis dot add up dot val. This is right. This is left. Okay, I think that's all. Now the only thing is if pair dot node dot val equal what is this dest val liu return pair node path. That's all. This is my final answer. Just is in case I'm going to add a fallback. Return empty string. Cool. Okay, let's go over the code once. This is a custom class I've created which has a node and a path. Okay, first what we do is where we initialize this hash map and we call the parents with a start value. What it does is um, if it is null we return. If the value is equal to my start, we store it as the start node. I put the parent current parent as p, call left and call right. Correct. Now here we have the start node available, visited set I have created, and queue, which is a queue of pairs. Now I add queue dot add the starting pair with the starting path is like empty path. Correct. And I have marked the start as visited. Correct. Now I take out the start. Let's run it for this case. So I take out. So I'll get 3 and empty string. This does not is not true. Up is map dot get 3, so should give me 1. Left and right should both be null, so these two would fail. Here what will happen is 1 will get added as visited and queue in the queue will add 1 and path would be u. Correct. In the next iteration I'll get 1 here. This would be false, these two would be null. Once parent is 5 should get 5. 5 gets added to this thing and then we process 5. Correct. So this looks like correct code to me. Let me try running it. Parents, because oh, I think I did not pass. Yep. Perfect. Sounds about right. N value is 10 power 5. Are we violating that in any way? So this is the first call where we're traversing the entire tree. This should be fine. We should be able to traverse the entire tree. And then here this is a BFS call. Yeah, I think this should work. Cool. Perfect. So yeah, that's about it for today. Yeah, this was the solution diagram. Approach again was since like we can anyways like traverse to the left and right, downwards you can traverse. The only limitation was traveling upwards. I sort of connected this to a graph approach where we do a BFS traversal. So in graph, if this was a graph question, it is very easy question. You start at a start node and you have to reach an end. You do BFS or sometimes you do DFS, anything. Here the limitation was we can't go up. So you need to solve that. To do that, we can. I introduced this hash map, which would store the parents as well. So left right I didn't store, but yeah, in a way you can create a new adjacency list or adjacency matrix, store all left right up, but yeah, during the storing, you'll sort of have to store them with the direction as well, like store the upward with U symbol. So here that was simplified because this parent map, this was for up, and left and right were segregated anyways, correct? So we need a differentiation of the three directions that we can go into. Cool. That's all for today. Please let me know if you need any additional help with this question. You need the explanation in Hindi or the code in any other language. Otherwise, I'll see you guys in the next one. Thank you.